In this video I want to go over factoring of quadratics. And this first type of quadratic that we're going to factor doesn't have any leading coefficient, so no number in front of the x squared. And it's always going to have a nice a rational solution. Okay, so if you remember the acronym FOIL, okay, which stands for first, outside, inside, last, is a way to distribute two binomials, meaning two of these things here. I'll do it down here in red. Okay, so if we have something like x squared plus 2 times x plus 2 times x plus 3, we can use FOIL to properly multiply these two binomials, meaning two terms together. Okay, and we do that by first multiplying the first numbers, meaning the x and the x, and that gives us x squared. X times x is x squared. Outside, which are the two outside numbers, so that's an x times a 3, which is just a 3x. Inside, which is just a 2 times x, which is 2x. And last, which is these last two numbers, 2 times 3, which is a positive 6. If we combine like terms, we're going to get that x plus 2 times x plus 3 is equal to x squared plus these combined to be a 5x plus 6. And that's how you appropriately multiply these two binomials together to get a quadratic. What we mean by quadratic is a polynomial with a highest term of, or a highest degree, of 2. All right. So what we're going to do now is we're going to reverse that process. We're going to take a quadratic that looks something like this and make it into two binomials. Okay, so you're going to have two binomials at the end of this process. Let's go through an example. Okay, example 1. We have x squared plus 11x plus 28. Now, how can I do this? Well, if I go back to my foiling example, I see that this 5x happens to be these two numbers, the 2 and the 3, added together. And I also noticed that this 6x, this 6 is these two numbers being multiplied together. And it turns out that that is the pattern, and you can kind of see it here with the foiling. So that's what I'm going to do. What you need to do is find, if you have an equation like ax squared plus bx plus c, you have to find two numbers that add up to b and multiply out to be the c value. Maybe I'll put these in different colors. Let's see. This is going to be the b and the c. Okay, so those are the two numbers that we're worried about. Remember, this a is just a 1 in all of these problems. Okay, so I have to find two numbers that multiply or add up to the 11 and multiply out to be 28. How you want to start these problems is you want to maybe, and you can do this in your head, I'm going to do it on paper, but you can do it in your head. I want to find all the factors of 28 and see which one of them adds up, which pair adds up to 11. Well, we have 28 and 1. I'll say 1 and 28. Why not? We have 14 and 2. 2 and 14. None of these work so far. Okay, we split this and we have 7 and 4. Oh, 7 and 4. 7 and 4, this adds up to be 11, right? 7 plus 4 is 11. So this is going to be the pair of numbers that I use. So I can factor it into two binomials with the numbers 4 and 7. So it's going to be x plus 4 and x plus 7. Now there's no order here. So this is equivalent to x plus 7 times x plus 4. Okay, those are both the answer. They're both correct. All right, but that is your answer. That's how you factor. You're undoing it. If you were to FOIL these out, that you would get x squared plus 11x plus 28. All right, let's try the next example. We have to find two numbers that add up to be 2 and multiply out to be negative 15. Oh, I apologize. Add up to be a negative 2. All right, let me just erase some of this clutter here. Maybe we can use this as our area to find all the factors of negative 15. So the factors of negative 15 are negative 15 and 1, negative 1 and 15, right? Both those multiply out to be negative 15. Can I think of any others? Let's see. We got 3 and negative 5 and negative 3 and positive 5. And I believe those are the only ones. So let's see if we add these up. What do we get here? Negative 15 and 1. That's a negative 14. No good. This is a positive 14. Also no good. Remember, we're looking for a negative 2. So this doesn't work out. What about our next one here? Negative 5 and 3. That is negative 2. So these are our two numbers that we're going to use. And it turns out you can factor this into x plus 3 times x minus 5. Okay, that's these two numbers here that we found. And that's how you factor, or kind of undo, this quadratic.